Hello, welcome. Today let's try to solve Leetcode problem 1048, longest string chain. So let's understand the problem first. We are giving words. So inside words, it is an array. So for the array, it is a number of different words. We just need to calculate the longest possible word chain. So what did I mean by that? So for example, we can find a word A. So A is a subsequence of BA. So for the next one, it can be BA. So for the next one, it can be BDA because we can delete D. After delete D, the sequence is the same. It is still BA. And for this one, we can delete this C. It's BDA. So here is BDA. And let's take another example. So for this one, A, B, C, D, but the sequence is different. If the sequence is different, even we can delete this Q, the characters are the same, but it will be just one, not two, because we need also to keep the sequence. Yeah, according to the description, we can solve the problems using like O if the length of the word is n, and if the length of the words array is n, and the length of the word is m. We can solve it in O n square m square, but we cannot pass it. If we solve it in O n square m square, we can use the longest increasing subsequence. So for the longest increasing subsequence, we're gonna use O n square. Basically, it's the length of the array, it's n, so n times n, it's n square. But for checking if two substrings, they have the common, the length of the common substring, it will be m square. So it cannot pass for the Leetcode because this words dot less, this n is 1000. Yeah, and we can also use this method to make it at least pass for the Leetcode. So this is also the longest increasing subsequence method, but this is for I and j. So it's basically for checking the longest subsequence O(n) square method. And here inside, I'm gonna use a length of word I, my current word, equals to my previous word, words j plus 1. And also I need to check. Yeah, this means just the length of the word is different. Of course, I need to sort the words first. So after sorting, so first of all, I'm gonna check the length of the difference. If this length is 5 and here the length is 4, it means it is okay. But I also need to check if this word I and this word C, if this word C is a subsequence of this word I. Yeah, it's a subarray of word I. Of course, it is not because I need to keep the order. Yeah. So let me prepare another example. For example, XB and XBC. So for those two strings, how can we check if this string is a subsequence of this string XBC? Because we just needed to delete this character C. Now after deleting C, they are equal. So we just need to use so I think this is also a Leetcode easy problem. We just need to use two pointers from the index 0 to check one by one. So yeah, after checking if this word I, the pointer for the I for the second word I mean this XB, if this I equal to the length, it means it is a subsequence. If it is not, we're gonna return false. It's not a subsequence. So according to this way, we can solve it in O(n) square m time complexity. So m is the length of each word, n is the length of the words array. It can pass, but it's still not so fast. You will see later to check how slow it is. Yeah, it will be like 1 second. It will be like 28% of all Python 3 submissions. Now we are going to use another method to make it much faster than this method. Now there's also some other method to check. Yeah, basically we have to sort the word first, because after sorting we're gonna check. Yeah, because the sequence inside the words, it doesn't matter. We just need to find the longest sequence. So why not sort it? Because this is a greedy. After sorting, it means according to the length, we can sort it. It means if the length is 1, it will always be here. If the length is 2, it will be here. Then it becomes the length of 3, and then length of 4. According to this way, we can check. So for example, for the first one, if we can put this word inside a dictionary, so in the dictionary for this character A or this word A, the length is 1. For this B, we put it inside, the length is still 1. Now we are going to put this BA. So how to check if we can delete one character from this BA to make it equal to A or B? So we can try two different ways. We can delete B. Now we are having A. So inside A is inside our dictionary. So we're gonna use 1 plus the dictionary DA. So DA is 1. So 1 plus 1, it is 2. Or we can use delete A, we can use B. So it is still the same. It is 2. So like in this way, the time complexity will be n times m squared. Yeah, because for combinations of all those words, it will be the length of the word, it will be m. And we are going to check if this word is inside the dictionary, it will also be m. So this is why I'm going to use O n times m times m method for solving the problems. So it's the same. I'm going to sort the word first. So the words dot sort. I can use two ways. So one is I'm going to use a lambda function. Another way, I just need to give a k equal to length. So basically it's the same. So we are just sorting the word according to the length. If the length of the word is equal, we're gonna sort it according to the ASCII2 values. So if so the BA will always be before BC, for example. This BA will always before BC. This A will always before B. So according to the ASCII2 values. So after sorting, I'm going to prepare two variables. So one is a dictionary as my counter. Another one is a result. So I'm going to return the result. So the counter will be dictionary and the result will be 1. Because the words will be at least 1. And the word is not empty. So the words I is more than equal to 1. Now I'm going to just loop through the word. So for word in words, now I'm going to put this word inside my dictionary and give it a count as 1. After that, I'm going to loop through the word. So for I in range length of word. Yeah. And I'm going to prepare all the combinations after deleting one character of the word. So for example, for this word, after deleting one character, it can become deleting. After deleting B, it will become CA. After deleting C, it will become BA. After deleting A, it will become BC. I'm going to prepare a sub word. So this sub word or substring should equal to the word I plus word I plus 1, because I plus 1, I is not included. Yeah. So here will be I and I plus 1. Now I'm going to check it if this substring is inside the dictionary. It means I'm going to update the dictionary for this word. So the word should equal to the maximum of the word. Yeah, why I use the maximum of the word? Because I will check all the combinations. So for this one, if I loop through one word, so this is one of the sub. I'm going to check all of the combinations of the sub. Maybe I have too many this is substrings. I'm going to check all of them. So it will be the sub plus 1. So here I need to plus 1 because I already find 1. But before that, what is the longest before my word? So current word I have a 1, and before my word I will use d sub. Yeah, and I will check one by one until I get the maximum value of this D word. Finally, I gonna get my result. So the result would be the maximum of the result with this D word. Now I just need to return my final result. Yeah, let's analyze something. So for here, we just loop through the words. So the time is just on. N is the length of the words array. And for here, I loop through the length of the word. So the maximum is 16. So I will use a variable m. So it is n times m. So here it will still be the same because this is I and all combinations of the substring. And for here, I'm going to check if this substring is inside the dictionary. So I'm going to use another actual OM. So that is why the time complexity is ON times M square. Yeah. So this sub is all the combinations. I will check all the combinations. Yeah. So if this one of them is inside the dictionary, I'm going to update the D word. So the dictionary for this word, the counter will be updated. It will be bigger and bigger. And finally, for this word, I'm going to, yeah, this is up to now, I'm going to update my word here. So for example, for the first one, yeah, so for the first word, nothing is inside, so it will be 1. So for example, if I'm going to loop through the first word, it is A. And for the subword, there's nothing inside, so I'm not going to loop through all those ones. Yeah, and the result will be just 1. But for the next one, I'm going to update it. So this is basically for the function. Yeah. Now let me submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. Actually, it's much faster. It is nearly 10 times the time complexity of O(n) square times m, because this is n times m square. M is a smaller value. It is only 16 maximum. N is 1000. That is why it is much faster. Thank you for watching.